Hi, you guys. Happy snow day. So here I've opened up the document and I just want to show you guys how I did the example problem. So this is the problem that I did and I used Desmos to help me. And then the problem that you guys are going to submit, this is your assignment, is I want you guys to just make up any square root function you want. Find the linearization and you guys can pick the A value. So I'm going to have like unique graphs to look at from everybody, which will be kind of fun. And then also do part B, which would be um, find by. So I think that's typed in here, but I don't know what happened to my cursor. Okay, so yeah, there's part B. All right, so how I did my problem is I just typed in the original function into Desmos. So here's my original function. I typed in a Desmos, and then I just snipped that right here. So I just snip that and here's my original function. So that's that cubic function right there. Okay, if we are supposed to find the linearization when x is 2, well, I evaluated 2 into the function and that's 7, and that's actually the dot I have on my graph. So that's where I'm just kind of showing my work that 2, 7 is a point on the graph. And then this is showing my derivative f prime of x, and I just type that into Desmos. Desmos doesn't really like that. That's why it does that little I don't know, error sign, but it's just kind of a nice way to show your work. Here I plugged in 2 into the derivative and I got an answer of 10. So that's kind of like our slope. So remember, L of x is f of a, which is our 7, plus f prime of a, which is 10, times x minus 2. And that's just an equation of a line. Now, right now it's not showing up, but if I just click it like this, here now you can see the equation of the line and it hits right at that point. So again, I took a snippet of that picture. So if you type in anything it does most, then you just kind of click on it here, it'll disappear, and then I'll come back. So I have the original function, I have my work for my linearization, and then I have my graph with the tangent line. So then part 2 is evaluate dy. So remember, dy is just the derivative times dx. Well, I already know the derivative is right here, and then dx. So that's the equation for dy. Then to evaluate it, I plugged in 2 for x right here in this, and for dx, I plugged in a 0.3. So what that means is on this graph, as I move over 0.3 to the right, so right here, if I move over 0.3, I would move up 3. So my dx is 0.3 and my dy is 3. So you're going to make up your own function, show me the graph, show me the work, and then you're going to do your own dx and dy, evaluate dy for your given. You can plug in any number you want. You get to pick your number for a, and then let's all use a dx of 0.5.